Good morning, AP chemistry students. I am sorry I cannot be there today. I'm home with a little under the weather one, but I'm here with you in spirit on the evening of the night of Halloween Eve. So today, what we're going to cover is section 3.8. And I don't know why I gave you a peace sign, but we could all use a little bit more peace, that's for sure. So we're going to cover section 3.8. So if you could get your notes out, and I know I had you watch a video on this already, and once you're done with this video, I'm going to have you and your friends and neighbors go ahead and finish the homework, which is on section 3.7 and 3.8. And then I've also added some questions to AP Classroom, which include gas law and solution problems, which are all included in this massive unit. But hopefully, especially today, you're going to start to see how all of these things tie together. So while I go ahead and get out my section 3.8 notes, why don't you go ahead and get out your section 3.8 notes? And that's what I'm doing right now. And if you need to pause, my section 3.8 notes are almost up. All right. Here we go. Do a little pen test, make sure my pen is working. All right, fantastic. So section 3.8 is about representation of solutions. And the video on AP Classroom that I had you watch had a bunch more particle representations, which those are really good and important for you to understand and to recognize. And so this is kind of in addition to that. So if for some reason you didn't watch that video and take those notes, which I'm going to ask you to show you, then please make sure that you do so. But basically, if we mix things together, which that is the definition of a solution, then those things will have some form of attraction to each other. And if those are two nonpolar things, right, 2NP for two nonpolar things, then they're going to exhibit dispersion attractions. If they're two polar things, two polar things, then they're going to exhibit dipole-dipole attractions for each other when they mix. If they have the capability of hydrogen bonding, which remember that is a polar bond, okay, but with hydrogen on the same atom and FON, hydrogen bonding is FON, fluorine, oxygen, or nitrogen, then they can't hydrogen bond. And then the most common force we'll see in solutions is this one right here, an ion dipole force, which an ion dipole force is when you have some ionic solution, such as sodium chloride, dissolved in water. And so that's an ion dipole. And so that's when you have some ionic substance dissolved in, I'm going to put water here, because 99% of the time it's water, but it could be any polar substance, polar solvent. And just as a reminder, the solute is the thing that there's less of in a solution, and the solvent is the thing that there's more of in a solution. Make sure you read through these paragraphs here. Okay, intermolecular forces exist between solute particles and between solvent particles, right? And then also between solute and solvent particles. Sometimes things don't dissolve, and maybe that's because the solvent particles are so attracted to each other that they have no attraction for the solute. That might mean that they're not miscible. So miscibility, I often think of it as mixability. Do things dissolve in other things? And the rules to remember: likes dissolve likes. So polar solvents dissolve polar solutes. Non-polar solvents dissolve non-polar solutes. And we have talked about this a little bit before when we were doing our chromatography. So hopefully that is ringing a bell. So the last thing I just wanted to mention right here, and again, make sure you pause and read these paragraphs, make sure that they're making sense, is the particle diagrams. First of all, make sure that the numbers in these particle diagrams match up. So if you get a solution of KCl, make sure that it's like, if KCl is KCl, so that's a 1-to-1 ratio. So make sure that the amount of potassium ions is equivalent to the mass of chloride ions. And then just make sure you also are comfortable with knowing the idea of like concentrated, which concentrated means lots of solute, the thing there's less of in solution per solvent, versus diluted, which means there's less of the solute per solvent. Okay. And so I'm not going to take the time right now because most of what we can do is more of just a discussion to draw out all of these. But let's just say, for instance, you're asked which solvent would be the most effective dissolving the following solutes, hexane or water. Identify the dominant intermolecular force between the solute and the solvent and draw out the particulate. And the solute is ethanol. And the key to note is the OH group. You guys probably know that OH group as the hydroxyl group. But if you see an OH, just know that it can hydrogen bond. If it can hydrogen bond, it's going to want water. That's right. And so anyways, if we wanted to dissolve this, that OH group would form bonds with water. And so it'd be way more miscible in water than a non-polar solute such as hexane, because hexane, it would only exhibit dispersion forces with. Okay. And then if we have something like a ionic compound like KCl, ionic is just really, really polar. So ionic solvents are always going to dissolve in polar solutes such as water way better than a non-polar solvent. So the we do questions here, we're going to go ahead and just answer some of the questions, but not necessarily do all the drawings here in the interest of time. So here we have an alkane, all CH, CH, CH. That means it's non-polar, folks. Okay. And then we have an alcohol, which boom, if you see that OH group, just be like H bond. Okay. And then ether. Okay. It's got CH3, but the C is connected to the O. There's no fluorine, oxygen, or nitrogen connected to the H. The carbon is connected to the H. And so this also is going to be a non-polar, maybe a slightly polar substance, definitely more polar than the alkane. And amine, anytime you see that group right there, now we have a nitrogen bonded to hydrogen. So this can H bond. And then what do we have at the end here? A ketone again. You got an oxygen and hydrogens, but they're not bonded to each other. And so this is the same situation as the ether. It's kind of a non-polar / polar. Okay, so of the following, which would hydrogen bond with water? Well, I think we just answered that. I hate to break it to you. That would be the alcohol, and that would be the amine. Okay, and which would form dispersion forces only? That would be all of the rest of the molecules. So that would be the ketone, the ether, and the alkane. Okay, there might be some slight dipole forces in both the ketone and the alcohol, but for the most part, those are just going to be the dominant force is going to be the dispersion force. If we had two alkane molecules in number 2 bonding together, the strongest intermolecular force would be a dispersion force, which is just, remember, an induced dipole where the electrons are just temporarily moved. And so this would just be a dispersion force. If we had the two ether molecules involved. Now, again, let's get in a little bit more detail here. The ether ones, because you have part of the molecule that is a little bit more polar than the other one. So let's go back up to our options here. we would probably have a little bit of this going on. We probably have a little bit of dipole force going on because the molecules are not exactly symmetrical. It's not just carbon hydrogen bond. So our strongest force in here would probably be the dipole and dipole force. Okay. So what I would like you guys to do is go ahead and do the you do section to the best of your ability, and then go ahead and check out the answer key, which I'm posting right now on Google Classroom. Just remember, like when you see number 2, so this is asking you to draw out water dissolving in a ionic compound, and in this case, it's some magnesium compound. Make sure that you have the right part of the water molecule oriented towards the +2 of the magnesium. I think that's it. Instructions. Go ahead and finish this. Check the answer key on Google Classroom, and then go ahead and finish the handout that you should have been given. And once you're finished with that, go ahead and check the answer key and make sure that you're really comfortable with both sections 3.7 and 3.8. And then if you're ready to go ahead and get ahead for the week, one thing that I'll be asking you to do is just some AP classroom practice questions in addition to other things that we'll be working on. And those are posted. And if you want to read ahead in the notes, we will be covering everything else that would be 3.9, 10, 11, 12, and 13 over the next couple of days, which you'll notice as you look at them, there are things that we've pretty much already covered, at least at some point, and so hopefully they won't be brand new. Again, sorry I'm not there today, but thank you guys for learning with me in the virtual world, just like we used to back in the day of Zoom. And I will see you mañana, tomorrow. Take care.